I have done so. So if anyone of the participants attendees do not want to for his face to be presented, just close the camera, or else you can have it open. So Dorleta, the floor is yours.
Okay. So hi everyone, thanks for making it to this final webinar of the 5 project. As you know, we have 5 main points on the agenda today. First of all, we will have an introduction to the 5 and project overall on the open call rooms. Then we will have the technical support coaching explained by Panos Xylofotos. Then Theodoros will talk about business opportunities. Then we will have 4 of our open call participants explaining their success stories, and then we will have a short slot for questions and answers. So I would like now to give the floor to Xenophon Vasilakos from ICCS. He's a project manager and senior researcher in the Intelligent Network and Services team in ICCS and coordinator of the project. So please, Xenophon, go ahead.
Hello, just a small verification. Can you see on the screen the shared presentation?
We do. Yeah, we do. Perfect.
Good. Thank you, Dorleta. Thank you, everyone, for being here today. This is going to be a very short introduction to 5G IANA and the open call rounds. I will try to squeeze as much necessary information as possible for understanding what this webinar is about. So, starting with a definition of 5G IANA. It is an H2020 Horizon 2020 ICT 41 project that was kicked off back in June 2021. And it's currently coming at the end of November at its completion time. It is comprised by 16 partners. The consortium is comprised by 16 partners, out of which 10 are small and medium scale enterprises. That is an important information to bear in mind, as this is why we are here today. Besides those small and medium scale enterprises, we also have third-party SMEs, which participated by means of external experimentation through 2 different open calls. Throughout these 2 different open calls, 5 out of these SMEs were awarded with funding. As you can see on this slide, the consortium spans 8 different countries, and it has 2 different testbeds, one in Nokia in Ulm in Germany, another one offered by Telekom Slovenia in Ljubljana in Slovenia. So let's try to understand what are the objectives, which will also clarify what we offer to the external experimenters. So 5G IANA offers the perfect environment, a pragmatic 5G environment to do trials for connected and automated driving relevant use cases. This is why we had the open calls. We invited everyone that had a service under the field of connected and automated driving relevant use cases to join and conduct trials with or without, that's not necessary, any prior knowledge about 5G telecommunications. In order to make that happen, 5G IANA offers 2 things. The first one is an open repository environment where you can host your own network application and your virtual network functions. And at the same time, you can get advantage of the available network applications by others and virtual network functions in order to design your own network application, do the chaining of the functions, and then have your own connected and automated driving relevant service. And the other thing, the second thing needed, is the automated open experimental platform, which is at the disposal of the third parties. This is where you can, with the use of automation tools, develop your service, deploy it automatically, and also test it automatically. So these are the 3 necessary things which we offer, and these were our objectives. Besides this, of course, since we are having open calls to small and medium scale enterprises and startups, we also coach them and try to help them out with forming new business opportunities, exploiting them, and to boost the market for the startups and SMEs in the automotive sector. Now, to cut a long story short, these are the 5 out of all of the participants in the Open Calls SMEs. For most of them that you see on this screen, you're going to have today a short talk about their experiences, starting from Open Call 1 with Link Robotics, and then moving on later on with Diamantis Group, Theron Technologies, Avisense, and Rhodes AI during the second Open Call. And as you can see, both of our testbeds were utilized in the context of these 2 Open Calls. All right, so without any further ado, I would like to pass the floors to the speakers, the next speakers. Just a small reminder, if you go to our website or if you quickly scan this QR code, you get there, you will find all the necessary information in one place about the project and the Open Calls. And that is by me. Thank you very much for your attention.
Thank you very much, Senfon. So now, the following point, we will have Thanos Xirofotos from UBTech explaining the technical support and coaching platform and testbed facilities and coaching scheme outline. So please, Thanos,
Hello,
go ahead.
I hope you can hear me and see my screen, right?
We do. Yeah.
That's cool. Okay, let me start. So, hello everybody. So on my side, I will give you some details related with the technical activities and how we supported the whole process of onboarding and bringing the new third parties into the 5G IANA platform. In a glimpse, 5G IANA platform is composed of these 3 layers, 2 vertical, 1 horizontal, 2 horizontal, 1 vertical, sorry. The only thing that I would like to point out here is that through the platform, the end user is able to bring their application and to design and use specific, let's say, components inside that platform, link them, and at the end compose the whole application in order to be tested. And another, let's say, gap that bridges the 5G IANA platform is how we interface with the different technologies that underlies from each infrastructure. So either cloud computing resources or 5G resources are totally obscured to the end user, and through this middle layer, this gray layer, it is able to be used by the end user without having any further knowledge or any specific, let's say, technical details about the technology that he is going to be used. So in general, through the 5G IANA platform, the end user is able to bring the application, their application, onboard it providing via images, Docker images or container images, or anyhow, it's totally related to the end user. Use this VNF repository where the containers and the images are stacked in order to be chained and create a graph, a NetApp graph. And the further step is to just obtain some specificities related to the deployment of the application on top of a 5G infrastructure without asking anything particular and anything specific to that is, let's say, complicated in terms of technology and in terms of requirements, technical requirements from them. Now, two things about this. The 5G IANA platform is being deployed in two test beds. One is in Nokia, which I believe that the third parties will also indicate where they did these tests. The Ulm test bed is in Germany, and it was the first that has been integrated with 5G IANA platform. These are particular information, but it is not very important to you. The only thing that needs to be highlighted here is that we were able to support 2 types of slices. Slices are bind with specific requirements from the 5G. So V2X slice, as you see on the top, is basically it provides low latency communication, while EMBB provides big bandwidth communication. Both of these two has been used. The other testbed is the Slovenian one. This is where the final event also took place. So the same applies to Slovenian testbed. It supports 5G standalone 5G network, and the two particular slices are the same of the same kind with Nokia. So V2X for low latency and mobile broadband for high throughput communications. Sorry. Now about the coaching methodology. So the only thing that we had when the only process we followed for the third parties is the following one. So in order for the third parties to gather the necessary material for being able to get them on board on 5G IANA platform are these. So initially we need one descriptor in order to be able to start the process, upload this into the 5G IANA project GitLab. The third step was to validate this, validate the consistency of this descriptor. This was a process that has been done as a coaching session number 1, as I indicated here. Fourth step was again included in the coaching session number 1 is to perform the deployment after we validate that. Fifth is to validate that the platform has this application already onboarded, while the sixth step is something that we were trying to identify with involved partners. So each individual from each individual third party was able to having, let's say, a pair programming, if we can say it like this, and validate that every container and all the application that is already in the platform is identical and it's ready to be functional. These sessions again took much time from the technical team, and after this step the application was able, let's say, to run. So we performed the deployments over the test beds they have selected, the desired test bed. And the last peer-to-peer session, again with the technical team, was to debug and validate that the runtime is the appropriate and the application is operational as they, let's say, draft their design to run. That's it on my side. So thanks again.
Thank you very much, Thanos. So now we will go ahead with Theodoros Prokas from Insights Consulting. Theodoros is the CTO of Insights Consulting, and he's been working for over 20 years with network operators, equipment vendors, regulators, and public authorities. So he's going to talk about the business opportunities. Theodoros, the floor is yours.
Okay. Can you?
Yes, we can hear you.
Okay, so perfect. Okay, I was trying to find the link. So, Dorleta, okay, already mentioned who am I. So, the role in the project was related to identify the business model, both for the exploitation of the 5G IANA platform and also to identify new business models for the experimenters and general third parties that are going to interact with the platform. So, let's try to understand what is the benefit of having a platform like 5G IANA. So the current status regarding 5G is that, okay, we have heard all the promises about 5G, but until now we have not reached the full potential. So although we have some deployments of 5G in almost all countries, European countries, the standalone deployments are still ongoing. There are issues regarding device compatibility, but the main issue is has to do with the adoption until now. But in order to have the adoption, it's need to have some application. So this application will come from the industrial stakeholders that then in their turn will present these solutions, this application, these new services that will run on 5G network that actually is the enabler for these new services to the end users. So that's where 5G IANA platform comes. So when we started the project, we have the vision of creating a platform that will interact with all the actors around the ecosystem and allow some new players, these network application developer and network application providers that until now are not actually part of the ecosystem, to come interact with the 5G IANA platform, create their own network applications, and then using some service provisioning role to provide these services to the end users. So what is in a few things, a few bullets, what actually the 5G IANA offers to someone that comes and interacts with the platform is to come and having all the tools that Thanos mentioned earlier to get the tools, even if they are not experts in with the 5G IANA network, with 5G networks, to come develop and deploy the new network applications by combining, for example, network applications that have others created or their own network applications, build them on top of other network applications and create some new services. Then they have the ability to come in a real 5G infrastructure that it's not something that you can find everywhere, and go test that actually their service is actually working as it was supposed to be. And also, we provided, as Thanos mentioned earlier, the training and support on technical aspects. And also, we provided some consulting and mentoring from within the consortium regarding business-related aspects. And one more thing that we provided that it's only provided by 5G IANA platform is access to automotive-related resources that it's not something that you can find easily or in the market. So, by providing all this portfolio of services, what can get an SME that comes and experiment with the platform, with the 5G IANA platform, it's they can promote the innovation research, they have some idea, they can go test this idea, create some new services that will run on top of 5G infrastructure. So by using this live experimentation with a live network, with a real network, they can limit the risk of innovation. They can validate that the use cases that they have considering are working as the way it is supposed to be working. This realistic testing applies this. And other important aspect is that they can this fostering collaboration means that they can interact with experts that are deploying their other network application, or they have interacted with experts within the consortium, so they have already established some new collaborations that are going to exist and start implementing some new collaborations after the end of the project, and of course to learn some new things that are related to the topics covered by the 5G IANA platform. So this is just an overview of the team that we form of mentors in order to support first the internal use cases that we have within the project, but more, and also the third parties that came through the open calls and experimented with the platform. And regarding some other aspects that we said about the mentoring, so we have organized workshops that was related on the business models and exploitation. And during these workshops, we provided some definition of what exploitation and what impact generation is about, especially if they are not familiar with the R&D projects. And then we provided some hints on how they can perform a market analysis, how they can use tools that are used in order to create a business plan like the SWOT analysis and the business models canvas. For all of this, we have created some templates, and after a couple of rounds of interaction among us and the open call experimenters, we have managed to create all this, especially and make them for each of the open call experimenters. And just to pass the floor to the next session. What actually are you going to hear what actually they get from the 5G IANA platform? Here is a list again of the participants of the open call. You can hear most of them in the next sessions. Then that's all from me. Here are my details. If you want to contact something for me, you can use this email. So thanks again.
Thank you very much, Theodoros. So now we will start with a round of the open call participants, starting with Avicense. We have Christos Anagnostopoulos. I hope I didn't completely destroy the surname. From Avicense. He's the okay, sorry. So he's a simulation and platform engineer since Avicense was founded, and he's specialized in deep learning, localization, and perception for autonomous vehicles. So please, Christos, go ahead.
Thanks for the introduction. I'm going to share my screen, give you a short presentation. Just a second.
Dorleta, no worries about the Greek surnames. We equally destroy Spanish names that are even longer, so it's okay.
Yeah. No hard feelings. No hard feelings. Can you see the screen?
Yes, we can see it. We're hearing you a little bit low, so maybe
Okay,
you can.
come closer. I will come closer.
Thank you.
And also, if you, Christos, if you can put your in presentation mode your PPT.
Yes. Just a second. I have some technical problems with the laptop. This thing, and okay, it's now better.
It is, yes.
Okay.
Proceed.
Okay, I have a video in a slide. I hope it will play. Never mind. We are Avicense. We are an innovative company that tries to advance intelligent vehicles, trustworthiness, and safety. In the context of the open call, we implemented 2 use cases that are totally aligned with our purposes: a localization use case and a cruise view geolocalization. We'll get in more detail in the next slides. And we use simulation data either from open data sets or the data generated by our own simulation stack. And we have chosen the Slovenian testbed for our experiments. But what were our objectives? Regarding integration, the main objective was to dockerize and deploy all the components in the ARM-based environment, and of course test them into an end-to-end manner and validate the whole architecture. Regarding the testbed, what we want to do is to efficiently use the 5G network resources and to have low latencies, because something that is very important in automotive applications, especially the end-to-end latency in terms of safety and safety and security. And finally, the use case objective was common in both use cases. The thing is that given a noisy initial GNSS, we wanted to reduce the localization error in both use cases. For this is a video. The first use case, the cooperative localization. The description is that knowing the absolute position of a car can be very useful in many applications, like prison parking, etc. But determining the absolute position falls short in some applications because there is also a very much level of noise inside. But what if we have a group of vehicles, each with a noisy GNSS receiver, but also they can communicate via 5G network? And what if, in addition, each vehicle has a sensor like a LiDAR that can perceive its environment and estimate the relative positions between him and the other agents? So, and if all these cars can exchange this information together in an efficient and fast way, we can create a cluster of cooperative cars, where each car will information with our deep learning based algorithm. We will process the inputted data, and we will this will result in the reduction of GNSS error for all the vehicles that participate in the cluster. So regarding the implementation, we use 2 OBUs. Our use case actually, we took the minimum number of cars, 1 OBU for each car. Each OBU communicates with over 5G. We use simulated data from Carla. All the raw data was simulated synthetic data, and we created these components, the list of components that will be described here. So we have the LiDAR odometer that was taking such input point clouds, the object detector for detecting the nearby vehicles. Then the output of the detector was fed to the tracker that was using also the time dimension. And then all this data were aggregated, and with the help of an MQTT to ROS bridge, they were transformed to MQTT message that was delivered via the 5G network to the other OBU. And in each network, they show the cooperative localization module that was actually running our solution, that using the information from all the vehicles, from both of vehicles, could reduce the overall error. These some indicative results that we extracted. On the left, we can see the red rectangular is the ground truth. The green one is the one that produced the noisy estimation, and the blue is our estimation that is very much better than the noisy output. On the right is a function called cumulative distribution function that plots the possibility of the error. The blue one is our estimation. Green one is the noisy output of the SLAM. So if you can imagine, if you are in the left of this figure, let's say that you have a better estimation. Now, regarding our second use case, which was the cross-view geolocalization. What is the intuition between these methods? We have a ground view in each car, and we have satellite images. So we want to integrate satellite imagery to the ground, to the vehicle's image, in order to achieve better localization results. And this is what we did in the context of this open call. We use only one OBU, that we use one agent. The other infrastructure was located in the cloud. We use the Ford Autonomous Vehicle dataset. So each OBU was sending, on the left, was sending a pair of images, and a car image and a satellite image, to the cloud infrastructure. Sorry, I apologize for this. To the cloud infrastructure that was the server cloud that was in the right part over 5G. The cloud server extract feature from both images. They correlate each points, and they produce a better pose estimation for the car that was returned to the car. And some visualization results of these methods. On top, we have the camera's views, left side view, right side view, and on the top, below, we have the satellite images. The red dot is the ground truth, the blue is the noise GS, and yellow is our estimated position. On the right, they are the same thing, but they are also drawn the paths. So, what we earned in the course in the context of 5G IANA, we were enabled to test our solution on real-world conditions. Of course, we provided technical guidance on new technologies. We fostered strategic partnerships within the communication experts, and also we could say that this allows us to validate our technology, our solutions. We can say that we level 1 tier level, especially for the cooperative and the cross-use geolocalization method. Finally, what we plan is to advance more the technology maturity of our solutions, to expand the deployment scenarios, because now the use cases were a little bit poor. We have only 2 agents, and the driving conditions were not diverse. And of course, always strengthen the business exploitation. We can build partnership with other stakeholders in autonomous systems and 5G ecosystems to promote our solutions. And that's it from my side. Thank you for your attention.
Thank you very much. Now I would like to give the floor to Tamir Epstein from Roads AI.
Hi, hello. I'm really sorry. I mean, I got to be here at the last minute, so I'll try to do it as fast as I can. Let me just share what we have. Can you see it?
Yes, we can see it correctly, and we can hear you well too.
Can you put it? Yeah.
Okay. So basically, what we try to test and to demonstrate is the LITO system, and the use case we selected was a speed advisory for bus stops. And we're talking about real-time communication between vehicles on the road, connected vehicles, and the system is designed so using the infrastructure, it will detect obstacles or anything that happens and transmit advisories to selected vehicles in order to to harmonize the driving over there. Basically, in our use case, what we tried to simulate is this scenario where we have a bus, and when the system detects that bus is leaving, it sends a message to the car. Right now, we're talking about human drivers, so it takes time for the car to react. But the message it sends is an advisory for speed. So at the end, when the car will be behind the bus, they both will be the same speed. So there won't be any necessity for another stop or anything like that. And with that, we can reduce aggressive brakes and reduce CO2 and many other things. So we tested it in Telekom Slovenia. Here you see we simulated it with 2 cars. So here we see the car is moving, the selected locations of the car, and when the bus starts to move, it detects it, and then it sent the advisory through the application we developed. So here you can see, actually, here this is me simulating the bus starting to move, and here you see the advisory where it's hard to see, but this is where in our log where the advisory was sent. So we got lots of support from IANA. It helped us to demonstrate it for the first time in a real network. The latency was very low. It was 59 milliseconds. We also enabled to integrate our software with the network computing edge computing. The network was great, amazing. I mean, it was there were no interruptions. Also, with in terms of devices and flowing and data flow. And we would like to thank the people from Telecom Slovenia. They were very supportive. We worked with Peter and Bojan, and really big thank you for them. So the outcomes, we validated real-time speed advisory, that we can do it over the network, and the feasibility of running the algorithm on the edge. From the business point of view, it was very helpful, the webinars and the support with strategic tools such as SWOT analysis and business model canvas. And thanks to this project, we can move to the next step, which would be pilot projects that we're trying to promote with traffic authorities and fleet and cellular operators, and look for partnerships to deploy our system. Thank you very much.
Thank you very much, Tamir, and also thank you very much for being able to make it with such short notice. So now I would like to welcome Berg Turanli from Link Robotics, the winners of the first Open Calls. Berg, the floor is yours.
Hello all, thank you for inviting us and hosting us in this event. And I'd like to share my screen first. I think you can all see my screen now. Everything's okay, I think. Yes.
Yes, perfect. Thank you.
Our experiment was in Nokia Technology Center Ulm. Upon initial discussions with 5G IANA team and also Nokia team from Ulm, we decided integrate our visual inertial navigation system with real-time kinematics for high precision positioning in a real 5G network. For our deployment was with Nokia One, but the product has its capabilities in also autonomous vehicles, agriculture robots, and also with some like smart city applications for using the centimeter level accuracy of the system. We utilize the 5G infrastructure in 5G IANA in means of low latency and reliable connectivity. We basically communicated with RTK ground station and the application server through 5G. The experiment was designed with 5G and experts and validated inside RTK with respect to RTK using solo only RTK as a ground truth in a live 5G environment. Like we successfully demonstrated the integration and performance of the system, highlighting precise and robust positioning capabilities in 5G environments. Also, like we also had the chance to had some insights about optimizing the product for further applications and work on deployment strategy. As a result, for example, we started also developing a project, a sub product for digital twin generation, and we are to test it in next year in Spain also, in a 5G network also. And 5G IANA was mentoring and guiding the design of experiment and facilitating collaboration across the project members and deployment of these 5G technologies in real world. This is the the image of this deployment, but I rather show you a video where you can have it here. I think I've switched to full screen. It was the live video shooted from the Nokia One. What we do is we take images from onboard camera and we synchronize with the inertial measurement unit inside the navigation box, means RTK box we have, through a GPU accelerated routine on an edge computing device. And in this case, we have some RTK connection, but sometimes it's getting lost or it's not very performing well. What we do is we take from camera images, take navigation information, and with synchronization with IMU, we can obtain localization information from the cameras. And with RTK service, we connect with 5G, and also we did the edge server parts, some part of it in the experiments. We just connected, but you can see with respect to ground truth and also the using only RTK and also our product, it seems to be performing all well. We did a testing for more than a 4-kilometer range, and that's all, I think. If you have any further questions, I can happy to answer them all. And also, I want to thank you again for inviting us to this event, also the open call and also this event. And I hope to be in contact in the future for future applications and also for opportunities. Thank you.
Thank you very much, Berk. Now, so last but not least, we have Konstantinos Maliatsos from Feron. Konstantinos Maliatsos is the co-founder and research and development head for Feron Technologies and an assistant professor at the Department of Information and Communication Systems Engineering of the University of the IANA. So please, Konstantinos, go ahead. The floor is yours.
Hi, can you hear me? Sorry about that. Okay.
Yes, we can hear you now. We cannot see you though.
Yeah, I don't know. I saw that. I don't know why the camera does not work right now. I was connected, unfortunately, by the browser. Anyway, I will try to fix it. However, in order not to miss any more time, I will start with a presentation. Okay, so I will. Sorry. Can you see my screen? And you can see it in presentation mode? Or?
Yeah. No, we can see the presentation.
Not in presentation.
Okay, great. So, hello everybody. This is Kostas Maliatsos from Feron Technologies for our project in road hazard detection system. So, Feron is an SME founded in 2015 in Greece. It's a type of university spin-off. We are, let's say, a set of postdoc researchers trying to offer some services for ICT research and development projects. In 9 years, Feron has managed to participate in more than 17 European projects and national projects. So one of them, we have, let's say, the happiness to be part of this 5G IANA Open Call. Okay, now I think it's better. Okay, now the objective of our project is to develop a robust real-time road condition monitoring system. The overall objective is to improve driver and passenger safety. And this is done by a system that is able to identify bumps, potholes, and other road irregularities. And after detecting them, transmitting this information back to the authorities or the traffic manager, the road operator, and the traffic management entities. And we were able to demonstrate this solution and implement a scalable solution that can be, let's say, applied in real-world conditions. And we are very happy to exploit the offerings of the 5G IANA in order to accelerate our system testing and validation. So as I mentioned, the main objective was the development and implementation of a dynamic and active vehicle safety system over the 5G IANA architecture. The objective was to reduce accidents, vehicle damage due to poor conditions and or inadequate maintenance of the road and transportation infrastructure. And this is done through continuous and monitoring of the road condition by our system. So this is a silly video, a GIF about the operation of our system. Practically, every time we have a bump, the sensor measurements, and namely the gyroscope, the accelerator, the magnetometer, present some peaks, some anomalies. These peaks are sent back through the 5G network to the infrastructure, to the MEC, to the roadside MEC, and the authorities are notified, and also this notification is sent using DEN messages to other vehicles that arrive in the area. So in order to look out, let's say, and adjust the driving behavior based on the fact that the road hazard is ahead. Now, when we build the system, practically this is the whole complete view of the system. We have two components, the in-vehicle part, the onboard unit, where we have the sensors, performing the measurements, the gyroscope, the accelerometer, the magnetometer. We have the GNSS service for positioning and timing. We have a 5G module that it is used to transmit the information through the 5G IANA network, a local filtering, local decision system, and this is all facilitated using the MQTT protocol. On the edge side, we have also the broker and the subscriber to the MQTT services in order to receive the messages. And then we have the main, let's say, intelligence of the system, which is the decision support, where it is decided whether this, the detected, let's say, the measurement, indicate an anomaly or not. If the anomaly is detected, then we use the DEN service, the DEN service provided by 5G IANA to disseminate this information to other OBUs, to other vehicles that are at the location. So finally, we have a visualization service, and of course, all the data are stored for further processing and further, analysis. Now, regarding the onboard unit, it is a custom-made onboard unit. Practically, we used our laptop, but generally we use a small single-board computer that is suitable for to operate as a vehicle PC. A sensor, a gyroscope, accelerometer, magnetometer, temperature, and environmental sensor. But generally, we are mainly interested for the gyroscope and the accelerometer. The GNSS module used one from Qctel in order to acquire the GNSS information for all for GPS, Galileo, and GLONASS and Beidou. So we had all the possible coverage, let's say. And the 5G module that is used to connect, to attach the network and transmit the information back to the MEC. The MEC functions now. We have 5 containers that were deployed using the 5G IANA framework that contained the MQTT broker, Telegraph, InfluxDB as a database to store the information, Grafana for visualization. We had 2 containers that operate in the OBU, implementing the measurement and the position and time service operation. And finally, we have the MEC container that is the anomaly detector. So we have the anomaly, the one that decides that the anomaly is detected and notifies the DEN service, also provided by links in our project in 5G IANA, to send this message to broadcast it to other OBUs. Now, okay, this is quite technical as a slide for the anomaly detection. I will not be very specific here. Let's say that we try to use some thresholds, and this operated very, very, very well. But given that the thresholds are vehicle dependent, they may not be suitable for other vehicles. So in this case, we also developed an algorithm that is based on, let's say, unsupervised learning techniques, meaning the detection of outliers in a statistical, let's say, variable. and we evaluated both anomaly detection algorithms with our project in our experiments, and the results were very, very satisfactory. So experimentation was done at the Nokia testbed in Ulm. First, we had some tests remotely, and we were able to deploy our services to the MEC and make, let's say, some dummy fake measurements in order to validate the operation of the whole chain. And then we did the real-world tests where we were able to use the test vehicle in Nokia and in Ulm to actually drive through the roads and detect some anomalies. Here you can also download the video from our demonstration, so the experimentation activities there. Now, from our demonstration, we were able to extract information about some road hazards identified in Ulm. As I said, the system was performing great. The measurements were stored and visualized, and we were able to also build, let's say, maps with these road hazards. Now, here is a note. The roads in Ulm are quite good, so initially we were not able to identify many road hazards, so we had to lower the thresholds and ask also Robert, which was our help there, and great help, and a very big thank you to Nokia for all the support, to try and hit the pavement deliberately in order to have some anomalies and some bumps and some potholes. So these measurements are accurate, but they are, let's say, deliberately imposed. But our solution seems to work better than expected. So from 5G IANA, we were able also to gain many things. First of all, we had the ability to integrate our solution as a network application into a 5G optimized framework. We had the opportunity to test our solution in real-world conditions with the support of a big company. We had the ability to interact with and collaborate with a coaching team that it was, they were very helpful. And also we were able to, they built us also a business plan for the next steps to follow. The mentoring and technical and support was great. We had also this financial support, which was great. And we are very happy. And the next steps include elaboration in the system in order to, let's say, validate it with different types of vehicles in a much larger scale and integrate with machine learning algorithms. And also integrate other functionalities that may, so for example, may include driving behavior and other safety-related functions. So thank you very much, and once again, great to work with 5G IANA.
Okay, thank you very much. So regarding the agenda, well, thank you very much also for making it in time to all the participants. So now it is the time to give the floor to the audience in case anybody wants to ask any question.
And also, it's a very good time for all of the presenters to open their cameras and to have a really nice screenshot that we can use. Thank you.
Okay, so Angel Martin Navas has many questions, I have to say. Has 6 different questions, so I think that I may, well, either Angel can participate or I can read them, whatever. I'm not sure if they have the permission to unmute Dimitris. Okay, then
Not everyone
hello,
has.
Mick. Hello, Mick. Now, Angel, you can talk.
Okay, now I can talk. Yeah, so I have a lot of questions, but the good it is good because it is interesting what you have done. I have attended in the past to other webinars that also you have done. So congratulations to you because the work that you have done is awesome. So, but in any case, I have some different questions as far as you explain in today's session. For sure, I won't like to give time also for others in the case there are other questions in the chat or whatever. So I don't want to take all the time for my questions. So, but in any case, in terms of data generation, I have the question about how do you provide that for experimenters? So it is quite clear for me in the case I want to push something to your edge infrastructure or to create a new service in your infrastructure, but how I exercise with vehicles, with data, with systems coming from devices is something that is more unclear for me. I don't know if it is clear what I'm saying.
We can try answering this. Perhaps either Thanos or Eduardo are better for this. So we can actually pass the floor to any of the external experimenters from their experience if they want to.
Can I start?
If you want to, this event is actually basically for you, the participants. That's why I'm trying to avoid intervening. Yeah.
Just regarding that generation, without explicitly trying to answer the question, since we use synthesized data, not real data, there was a data set provided by us that was integrated in the infrastructure.
Okay. So you maybe push through ROS or something like that in order to use IANA as a.
Yes.
Okay.
Like
Okay. Then I won't go one by one because I think that others maybe or there are other questions in the floor, but the typical I will say the typical question that is okay. So did you receive as the consortium some feedback from experimenters that push you to change something in your plans, in what you have in the vision of the developing the platform or something like that? It will be something that I guess that is interesting for everybody that is also involved in creating such kind of applications and also platforms. So it is related to my question for, yeah.
This is a question for the platform or for the third
For
party?
the platform, for the platform. Yeah.
So there are some requirements that has been missing when the use cases and the third parties started to test their application. Particular and significant, let's say, where the minimization, let's say, of the platform's footprint in terms of resources, because OBUs were very limited in terms of how much CPU, RAM, things like this were providing. So we had this. We have managed to minimize this after some iterations and some further developments. There are also, so my answer to your question is that there are features that has been added as the reason of testing and extra requirements that has been given by the third parties.
Burada daha kritik bir problem var.
Can you mute?
I can hear you well. Yeah.
Okay. And there are also some features that has been carried out and didn't manage to finish this in order to also facilitate extra extra requests from their side, such as the debugging session. So one feature that would be nice to have in the future is involving debugging logs and session that can be exposed to the third parties and not to the platform provider. So there was this, let's say, peer-to-peer sessions where the platform provider, the platform from my side, I was just sending logs to the end users. That would be good to have access to them and bypass me. But I mean, it's something that perhaps we could take as a lesson for the further developments here. So to answer to your question in a small, let's say, in few words, there are features that has been implemented because there was absolutely mandatory that we have managed to add them in the platform, and they have also some features that was minor, which we didn't, let's say, had the time to add them.
Okay, and my last question is the other way around. So for experimenters, I saw that some of you have keep somehow the decision, the processing of data inside the vehicle. What do you miss from 5 IANA in order to say, okay, let's push also that from the vehicle to the edge and just keep the most simple and slim thing on the vehicle? What do you think that it will be necessary there in order to convince you to say, okay, let's push everything to 5 IANA?
Okay, thanks. Not sure if there are any more questions from anyone else.
Can I try to answer this? But if I understood the question correctly, well, actually, the experience with 5G was quite satisfactory on our side. Well, we had very few things to tackle in the experiment, and that was the pleasing thing, that things worked smoothly in general. So I didn't have any let's say issues or wishes that were, let's say, to make the experiment better. One note that I could do, let's say, feature that would make the experience better was to actually, for example, in our experiments, we used sensor measurements and we had to provide our own sensors. It would be nice if we had the vehicle with the, let's say, onboard sensors, the sensors that are exactly, let's say, from the vehicle. But I understand that this requires, for example, modification of the car and may not be, let's say, part of or maybe difficult to happen. But just that as a note, that maybe, let's say, if we had the in-vehicle sensors, things would be more automated, let's say, more. But just that, nothing else.
Okay, thank you so much.
Fine. Let's see if there are any more questions in the Q&A section. Yeah. Vincent Bono, let me find you your microphone. Okay, you can ask the questions yourself.
Yeah, I'm working for the SNS Hubs project, so we are looking at ways to promote entrepreneurship in SNS in general. So it was interesting to see there are not just SMEs, but in fact there are startups, spin-offs in the open calls, and so I'm really interested to understand. I mean, how it was promoted. So there was already an answer from Xenophon in the chat. But how do you make sure to reach as much as you can? I mean, to startups. I mean, do you have already people in mind? Do you go for specific publications and so on. And I don't know if you can share the information, but how many applicants did you get? That would be the kind of thing. But I'll be happy to discuss also those things offline. So I'm discussing with a lot of the projects that have organized open calls.
May I attempt to just recap because I answered on the chat?
Yeah.
So the intention from our side was, first of all, we didn't have anyone particular in mind, of course. The intention was to make it as publicly open as possible. And we know, of course, that our own website is always a starting point, but it's not necessarily the place that everybody knows where to check. So that's why we use social networks. That's why we disseminate from relevant email lists, which was the directive within the partners was to disseminate as much as possible within a national level and international level within Europe. And we also kindly requested people either when submitting to email lists or on individual contacts to kindly request to further disseminate. Now, if I remember the numbers correctly, I think, and please correct me, Dorleta and Dimitris, that we overall had at least 10 applications. Is that correct? Yeah.
Yep.
But let me note one more thing. There was also a strong encouragement by the Commission to try to engage SMEs that were not already funded within that ICT 41 round. So that also posed, let's say, a restrictive restriction. Other than that, the result might have been into an even wider pool of possible SMEs and startups to participate. But that was not up to our hands.
Okay.
Just to add, Xenophon, just to add here, okay, we also
Yeah.
use made some announcements to national contact points, okay, just because you mentioned this, we use all the mailing list of 5GPP 6G EA now, okay,
Yep.
to candidate. We have presentations in the SMEs working group through the partners of 5G IANA social media and all the local, let's say, networks, just to mention some of them, okay. But we have tried to promote it. Also, we found some specific SMEs that are dealing only with the automotive sector from some directories online, and we sent some emails to them. At least that's, I don't know if I'm forgetting something, but more or less, I think I have covered all of them.
If you have any feedback about what we could have done better to make this even more open, we're always open to get feedback.
Well, in fact, that's somehow my question, I mean, but
I think he asked you to organize the open calls in his project.
No, it's more about, so it looks, I mean, it will be interesting probably if possible to talk to some of the startups to see also what they already mentioned what was good in the program regarding the mentoring, the access to real time and so on. So I'm trying to see if there are additional gaps that could be filled whatever the way, not necessarily during the open call. So I'll be happy if I can discuss with some of the participants offline to see what was missing still. I mean, what they would like to see in, not necessarily an open call, in fact, I mean, in general. So I mean, if it's possible, I mean, I'll be happy to be in contact. I mean, I think there were emails in the presentation. You're probably going to share that anyway, so I'll follow up on that. I mean.
Yeah, just one more note that from our side, we also contacted local company development agencies because they have like a wider network of companies and so on. Just one more note on that. Okay.
Thank you.
So it's already 2 minutes past the time, so I think it's time to call this off. Thank you very much to all the participants, particularly those from participants from the open call for making it to this webinar. Thank you to all the participants for all the audience. Thank you for the questions too. It's been a pleasure, and so that's it. So thank you and bye bye.
Thank you, Dorleta. Bye.
Thank you, everyone. Thank you, Dorleta.
Thank you.
Thank you, everyone. Bye bye.